Hi Level 3s. So we're going to look today at the centre of mass. So it's a continuation of the translational motion topic. Now remember that translational motion is motion in a straight line. So we'll discuss this a bit further as we go. So the centre of mass of an object is always thought of as the point where it could be the center of the object, although if it's an irregular shaped object, then it's the point where gravity seems to act through. So if you took a look at the bus on the left here, standing on the slope, you can see there's an arrow acting downwards, and that would represent the force due to gravity acting on the bus, which is always downwards, despite the fact that the road is banked. And the support force in this case means that it's going to be at an angle perpendicular to the road surface, because the road surface is sloped, so that angle will be, that arrow will be at an angle. In example 2, which is the one on the right, you're again going to have a gravitational force acting through the center of the bus, or the center of mass, and this time the support force will be at a larger angle because the bus is on a steeper slope. So keep these force diagrams, free body diagrams, in mind when we go through this topic. So look at this now, using those concepts. If the truck is standing stationary on a flat road, here on the left, we can see that the forces will seem to act through a point further to the left because there's more mass on the left of the truck. But on the right here, on this thing that pops up every now and again, it's a little bit annoying, sorry about that. But this truck on the right, now it's on a slope, we can see that the center of mass will now fall just on the edge of the wheel of the truck or of the van. And so what happens then is, if anything, even if this little book, this large bookcase or whatever it is inside the truck, falls over to the left, that means the center of mass will be just over this wheel, and that means that the truck will topple over. So here is the absolute limit on this diagram for this particular center of mass. It's the limiting angle, or the topple limit. Another example, if we take a ruler and we suspend it from the ceiling or from a retort stand or something, from its center, so it will be halfway along the ruler's length, then there will be a center of mass that is experienced by the ruler through that point. So in other words, if you balance the ruler on the tip of your finger, where would you balance it? You'd balance it right through the center, right? Or the middle of the ruler. You just find that midpoint. Now, if you pushed or applied a force through that point on the ruler would move in translational motion. So if you held the ruler on the balance point and you applied a force, that ruler would not rotate, it would translate, meaning it would move in a straight line, in a linear line. However, if you apply a force anywhere either side of that line, that would mean that you would cause the ruler to rotate. It would flick up if you pushed on this side, or flick backwards if you pushed on this side. So it would rotate. It would experience a turning moment, or a torque. And you remember torques from level 2, that if you have torques, remember the formula for torque is force times distance. So if, for example, in this diagram, just very briefly, if you've got two masses, and this over here would be a point of balance, which these two masses will be balanced, and you have equidistances, and so F1 times D1, which is this distance here, and F2 times D2, so F being the force, 1 kilograms times the gravitational acceleration, which is 9.81. If you multiply those things together, you would find they'd be equal. Right, but on the right-hand side here, you've got unequal masses. And so the center of mass of this system will be to the left, right? So now we're going to use F equals mg in this equation. And we're going to use an x instead of a d. And the x here is going to be the distance to the center of mass. Right, so if we consider two masses as a system, here large mass and a small mass, then the center of mass will be at a point where they would balance. So the force due to gravity, mg, on this object, and force due to gravity on this object, mg, will be mg, and the distance between them, d, but note I've made the distance between their center of masses, so that we're going to call d, and then we're going to find the center of mass, and we're going to call the distance from the large m, the large mass, to the center of mass, we're going to call x, capital X, and the distance from the center of mass to the small m, the small mass, we're going to call small x, lowercase x. Then if you look across here, large m times g times x equals small m times g times x, right? So that was basically force times distance equals force times distance. So we're saying that the system is balanced. If we take out the g's, because they are the same on both sides of the equation, then we come up with mx equals mx, right? Okay, we can rearrange this to form capital M over small letter m, so large mass over small mass equals large x, over small x. And if the distance d is known, then we can rearrange that or substitute d minus x in here to find, because we've got the distance d. Right, so that equation might be quite useful. So make a note of that last equation as well. Now, if the point of reference is outside of the system, so here let's say our point of reference is this line on the left here, then we would have a distance to the first mass, a distance to the second mass, as well as a distance to the center of mass. Then this equation would apply. So in other words, the distance to the center of mass equals m1x1 plus m2x2, where you can see that m1 and m2 are the masses, divided by m1 plus m2. And this is only used when the point of reference is outside of the system. So the concept of the center of mass is that of an average of masses factored by their distances from a reference point. So in class, we are going to work through a few examples in your text, and then we're going to do 7D question 1. So make a few notes from these slides, and we'll do this continue on Monday.